Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETOS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETOS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Welcome to another episode of Empowering Tomorrow's Automotive Software. I'm Eric Sessa, your host for Empowering Tomorrow's Automotive Software. And today I'm here with John Wall, Senior Vice President, Head of Operations for BlackBerry Technology Solutions, to talk a little bit about the software-defined vehicle, of course, the future of our industry, the technology that'll be needed to drive it, and what role BlackBerry QNX might play in all of this, and of course, obviously, to get John's thoughts on all things SDV. The two of us, obviously, we've been in the industry for quite a while, and our paths have crossed a few times. But for the audience, John, why don't you give a little deeper peek into your background?
Absolutely. Thank you, Eric. Happy to be here today. So I've been part of QNX since 1993. So you kind of say I came with the building. So I've worked in the engineering group at QNX. I've done all the different jobs within engineering. In 2004, we were acquired by Harman. And if anybody knows Harman, we were part of the Becker group in Germany, where we really cut our teeth on infotainment systems. We did projects with Audi, BMW, Porsche, etc. And then in 2010, we were bought by BlackBerry. And while a lot of the QNX folks went off and worked on handsets and the Playbook, if anybody remembers that tablet from the early 2010s, I continued to run the automotive team and to rebuild up QNX throughout the 2010s to about 2020. And that brings us to today, which is, very exciting chapter in automotive, software becoming a dominant piece of the car of the future. And for me, it's a really exciting time.
Yeah, so thanks for the background, and obviously thanks for joining us today. So that kind of leads into my first question, and maybe you already sort of answered it, but software-defined vehicle, obviously it's a pretty hot topic, but what's your thoughts? Is it a buzzword, or is it something that's real?
Yeah, I mean, I think it's I wouldn't call it a buzzword, but I would call it the word of the day. Certainly, it's been used a lot in the last year. I attended a conference in June last year, 2022, AEK in Germany, and it was certainly the prevalent theme. Everybody was talking about software-defined vehicle. Personally, I believe that we're already on a path. The cars are already to an extent software defined. If you look at, reconfigurable instrument clusters, you look at, some of the features within the vehicles today. I mean, it's already headed on software defined path, but I think there's a lot more work to be done.
Yeah, okay, so that you're like segueing into my questions perfectly, but like, okay, so what is that work that makes it a reality?
You mean
Okay,
going forward?
that's Pandora's box maybe, but highlights.
Yeah, I mean, I think the panacea of what people would like to see, especially the OEMs, is some type of software platform within the vehicle that would allow the easy addition of new applications and new features within the vehicle. When I think of a truly software defined vehicle, I tend to think about cell phones and kind of the evolution of the cell phone, where you had a lot of different ecosystems, not a lot of applications, and then we started to consolidate the platforms, and you started to see a lot more applications. I think to draw the analogy to the car is tough, because the car is much more complicated. And I think it's going to take a lot more time to get to kind of that level. I think really when you think about software defined vehicle, at least in my opinion, I think of a broad and rich ecosystem for the car.
Yeah, but do you think that the auto industry coalesces like the mobile industry did on a couple of different platforms that really are the foundation, let's say, for the software defined vehicle.
Yeah, I mean, I think that's the question, and
Yeah.
and because as I mentioned, the complexity here is much higher. Uh, I think the if I think about the if I do draw the analogy to the handset versus the car, I think one of the fears is you never want to be relegated to a hardware platform with somebody else owning the software. I think if you look at Android handsets, uh, it's very difficult to distinguish handsets apart from each other on the Android side. Whereas if you look at Apple, that own the software, they own the hardware. They have, I think, a better proposition, generally speaking. So I'm not sure what's going to happen in the future, but I think there's a long way to go before we get there. I think there's a lot of complex problems that need to be solved before we can even think about that.
Yeah, certainly. Yeah, I don't know. I mean, we've been in the industry for quite a while, but the rate of change right now is something that I haven't seen in my career.
Yeah,
Uh,
neither have I. I mean, the rate of the rate, I would call it the rate of desire to change, I
yeah,
think is
yeah, that's a
higher
good way
than,
of putting it.
yeah, I think is higher than the actual rate of change. I think there's, again, if you really start thinking about the software defined vehicle as, the way the takeaway I had at the conference and since then has been really when people talk about the software defined vehicle, they're really talking about centralized compute.
Yeah,
If I were to take it to when it's really become a term, and centralized compute with the superscalers playing a big role, be it Amazon, Google, Microsoft, or other cloud players, and being able to move workloads from the cloud to the car and from the car to the cloud, and to have this ecosystem. I still believe that's a number of years off.
yeah, certain. I mean, obviously, we're part of that equation, and I would totally agree with you. What we see today is we're a ways off. I think the the traditional OEs are starting to starting to, let's say, design the platforms that support it from a hardware standpoint. But yeah, I think we're still a little ways off, and you'll see, in my opinion, you'll see um, an evolution, not a step change.
Yeah, I think that's actually right, and the comparison I make that's not that far back is if you remember back to CES 2014, where autonomous drive became the rage. Everybody was talking about autonomous drive, and statements were being made by some pretty important people in the industry that, hey, by 2020 you'll be buying cars without steering wheels. And you know cars still have steering wheels as far as I
Yeah,
know
right.
at the dealer, and I think most people want cars with steering wheels and gas pedals and brake pedals. uh, I think the path to autonomous drive is very going to be very gradual. Cars will have uh, more and more safety features, more and more ability of controlling certain situations, and it's going to be a very gradual step towards that, which is going to be a you know kind of bringing the consumer along at a very slow pace and getting them much more comfortable with it. And I actually think a lot of that will drive the software defined vehicle as well, as the car gets more autonomous, more processing power, more high speed networks, more sensors, etc. And I think you're going to see the same thing with applications and moving workloads from the cloud to the car, etc.
Yeah, it's interesting because I think the software defined vehicle can exist without autonomy, let's say, but the autonomous vehicle I don't think exists without the software defined vehicle.
I would completely agree. I would completely agree. And again, I think the autonomous piece, will be driven more by business needs. So I think we're going to see
Yeah.
trucking and industrial applications before we see the consumer application.
Yeah, and those are probably okay, not to belittle the the development or the engineering tasks, those are probably easier applications than, everybody's vehicle in their garage that they ask to do a bunch of different things with.
I would agree. I mean, I think first of all, you can spend more money because it gets amortized over a greater
Yeah,
use.
yeah, that too.
So
Yep.
so the money is not typically going to be the issue. You can put more expensive sensors in those vehicles. If you look at a robo taxi that's got a 24-hour life cycle, it can recoup that money. The
Right.
consumer is very sensitive to cost, and that's why I think it's just going to be gradually safety features added to the vehicle.
Yeah, I completely agree too. So what are you guys doing in this space today?
Yeah, so I mean, our role, I always like to talk that our role is a very small role, a very thin layer, but a very important layer. So,
Yeah.
we're building a real-time operating system, a real-time hypervisor, and middleware. We like to describe our role. So whenever I'm doing investor conferences, you know, it's this is a very complex world. So the way I kind of describe it is we're the plumbers and the electricians. We're what's behind the walls, what's underneath the floor. You don't see us, but everything rides on us. So applications within the vehicle, additional software layers such as adaptive AutoSAR, et cetera, run on top of our software. We're the abstraction to the hardware. So we're the abstraction to the CPU. And it's our job to provide, the base level of functional safety and the base level of security, and to provide the highest performance possible.
So from your perspective, I think obviously you guys have been playing a pretty prominent role in the plumbing side of things, as you like to say. But like, what do you see as, let's say, factors or aspects that will impede or maybe slow down the evolution that we're talking about?
Yeah, I mean, I think when I look at the software defined vehicle in the context that we talked about, centralized compute, I have the four horsemen of the apocalypse that I like to talk about. And and they're scary things, but they're problems that need to be solved. I
Yeah.
think one is scale, the scale of these systems, the amount of workloads that are going to need to be handled, uh, how vehicle engineering is going to be handled, and in a lot of cases, how the OEM. I mean, you know this, Eric. The OEMs feel the need to own a lot of this because they believe it's going to be a differentiator for their vehicles.
Yeah. Right.
You don't. BMW is not going to have somebody generic design their engines if they think their engines are a differentiator for their cars, which they have
Right.
been.
Exactly.
So they're getting involved. So being able to spin up these teams, and it's not just going out and hiring engineers. You have to have structure. You can't just hire engineers at a school and expect to be able to build great stuff. You need to grow a team. You need to grow the management. You need to grow the pedigree of that team. I think the other piece is the complexity. The car is a complex thing. There's multi operating systems. It's not just one operating system. There's classic AutoSAR. There's going to be adaptive AutoSAR. There's going to be Linux. There's going to be Android. There's going to be software like QNX. Bringing all that together. AI, ML is going to play a big part. And then with all of that, you have to still maintain the highest levels of safety and
Yep.
security. And you're going to have these mixed criticality systems. If we truly get into centralized compute, you're going to have a mix of safety and non-safety, and then you're going to
Yeah.
want to
On a
deploy
single device, right?
on a single
So
device. Yeah,
yeah,
that's which right away I look at that and I go, I don't think that's going to happen for a while. I
it's
don't
complex.
see. Yeah, it's very very complex, and then you bring the cloud into it,
Yeah.
and the superscalers are going to play a very large role. They have certain ways of doing that, but the cloud environment is very different from the car environment. The cloud environment, when you think about it, it's resource unlimited typically. So spinning up new workloads, managing those
Right.
workloads, managing the life cycle is they know how to do it. It's very well understood in the cloud world. they're trying to bring a lot of that technology to the car, but the car is different. The car is resource limited, has only so many cycles, so much CPU at the moment, and so things need to be managed very, very carefully. And the car typically tends to be very static from a software perspective. You build a load, it gets tested, it goes into the car, and you hope not to revisit that until there's a problem or you want to do a wholesale update. So the idea of adding workloads and managing these new workloads in the context of not interfering with existing processes and existing services within the vehicle, it's very complex.
It's almost in my mind, it's sort of a paradigm shift, because you're right. Like today, in today's world, you you release a software package for a given vehicle, and maybe you hope that you never touch it again, right?
Yep.
And what we're talking about with the software defined vehicle is to continuously update a vehicle, and one vehicle, maybe it's the same make and model, but it could have a completely different software landscape on it.
Absolutely. And we're not only talking about updates, we're talking about new workloads, new
Yeah,
features within the vehicle. And so,
right.
as a software company, as plumbers that I talked about earlier, plumbers and electricians, some of the areas that we're really focused on is, obviously, we've talked about the operating system. We have a new operating system coming out at the end of this year that is, geared towards the next generation 8, 16 core, 32 core processors. The idea is that this operating system will scale 1-to-1 as you increase cores, or even being so bold as to say it's going to be the best scaling OS uh, available to the car, bar anything, not RTOS, but OS. And that's going to extend to the hypervisor, which is built on the same platform. But the other things that we're looking at to try to help this is, how do we create containers or something similar to
Yeah,
containers that can move workloads from the cloud to the car, be OCI compliant, so that all the tooling that people are used to in the cloud world continues to work, but
yeah,
that it can be done in a safety certified way. And, a lot of lay people get confused with containers. They think containers are just a payload, that it just delivers something from the cloud to the car, but it actually runs in the car. It's actually its own environment, a runtime
right.
environment. So it needs to be safe, functionally safe and secure. And so this is something we're very focused on. And, that's kind of where we see our contribution to the software defined vehicle, is to take care of some of these tough plumbing problems and to have solutions.
Yeah, because they aren't trivial really in the end,
No, they're
right?
not. They are not trivial. Uh, and I think it's important to note they're not problems that need to be solved tomorrow. So there's time to actually work through them and to actually solve them in a way that makes sense, and a way that's sustainable in the market. Uh, there's a lot of people, again, that believe this may be happening next year. Uh, I don't think so. I think to your point, it's going to be gradual. So we have
Yeah.
time to work on good solutions.
Yeah, right. I mean, I think we're both in the middle of the same sorts of development cycles with customers, and I,
Yeah.
I mean, I think um, it's not possible to that some of the stuff hasn't been invented yet. Let's just say it
Yeah.
that way, right?
I think that's a perfect way to describe it. And that's some of the things, like, I'll be honest with you, we're not even convinced containers are the answer. We're looking
Yeah,
at 5 or 6 different solutions, and we're visiting with our customers and having discussions with them, and trying to suss out what is the right solution.
what's your guys' take on the open source side of it?
Yeah, so from the open source side of it, I get asked this a lot, because people believe that we are close-minded to open source because our product is not open source. But I think it's important to note that a lot of what we do relies on open source. For instance, our networking stack is BSD
Yeah, okay.
derived. We've actually created a team within QNX that is designed to take the common open source projects that people use on QNX, port them, optimize them, port the actual test vectors, and push them back up into the community so that the community can support it and move it to different versions of the operating system if that's what the community wants to do. So we actually are very, we embrace open source. For instance, we just recently pushed up to the open source Rust programming language support in working in conjunction with Electrobit. And we've already seen people have taken it. The community has taken it from 7.1 to 7.0, minor revision number of the OS. So we are going to continue to do more and more in the open source community. I mean, will we open source QNX? Maybe at some point in the future.
Interesting. So, do you think that there's any way this technology that we're talking about in the automotive side, moves to different industries? Maybe outside the transportation space, because we talked about a little bit about, off highway heavy duty, maybe
Yep.
in industrial technology, which I would
Yep.
consider transportation. It's the same sort of technology.
Yeah, I would agree. I think you read my mind because that is something that I talk to my team about all the time, is that we're at an inflection point and automotive is front and center and driving it, because I think the automotive use cases are cool.
Yeah.
People like cars. Autonomous drive is cool. The whole idea of a software defined vehicle, I think, is pretty cool. But QNX comes from a non-automotive background. Before
Right.
we were bought by Harman, you know, we actually work with your team, some of your teams at ETAS, in non-automotive, not specifically non-automotive, but more in the test equipment area.
Yep.
And so we are starting to see things. The similar things are happening in other markets, such as medical and robotics, which is a move away from smaller ECUs, like MCU based systems, to MPU, higher performance. We're starting to see a need for functional safety. If you look at medical systems or medical robotics, we're starting to see cooperative robots. And so we're starting to see a lot of the same properties that are happening in automotive happen in kind of non-transportation related markets. And for us, it's wonderful. We're seeing new markets open up to us that we maybe moved away from when we got into automotive. But yeah, we're starting to see a lot more synergy with what we're doing in automotive in other markets.
Yeah, you're right, because I mean, and from my perspective, yeah, the software defined vehicle is one of the drivers for this, but I think also autonomy is, because you're
Yep.
talking about connecting the vehicle to the grid, to basically, every other device that's connected,
Yep.
just as an
Exactly.
information source. So,
Yep. Yeah, I didn't even mention that. I mean, everything is connected.
yeah, right.
I don't even think about it anymore because
I know.
literally everything is connected.
Yeah, yeah. So, John, thanks for the time. That was a wonderful conversation. I really enjoyed it. Any, from your perspective, any things I missed, or anything you want to let the audience know about?
No, I mean, I think I don't think you missed anything. I think it's going to be a really exciting journey.
Yeah,
I think complexity and hard problems to solve is kind of what I think drives a lot of us. If it were easy, I don't think it would be that interesting. So
yeah,
obviously
true.
I know, and what I think is really great about it as well is that it's not one company that's going to solve these problems. It's a collaboration amongst a lot of different companies, and I think that's a really enjoyable part of automotive.
Yeah, certainly. It's definitely a fun time to be in the auto industry right now, I think.
Yeah, absolutely. And I really want to thank you for having me on today. I really enjoyed it.
Oh, thanks. No, my pleasure. So this will conclude our episode here with Mr. John Wall and his maybe some of his insights and some perspectives from BlackBerry QNX. Check back soon for our next episode. Thanks for listening, everybody.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.